Hey guys, so this is the third attempt in making this video. The first time my cat was on the oven. The second time I recorded like 5 minutes into the video and the sound wasn't on. So we're gonna try this one last time. And if it doesn't work, it doesn't work. So last week we talked about proportions, we talked about confidence intervals and significance tests and how to put them together. This week we're going to be talking about means. Of course, how to do confidence intervals and how to do significance tests and then putting them together. You're going to notice some similarities between last week and this week. But right now we are looking at confidence intervals day one. So for the confidence intervals, the first thing that we're going to do is state. This is trying to figure out what do we know. So in this case, we're going to be stating the null hypothesis, the alternative, the null mu. We're going to be looking at that sample size, the sample mean, the standard deviation, as well as, we can do the degree of freedom if we want to. Remember, the degree of freedom is equal to n minus 1. And then, of course, you have to state what is the parameter. So you're going to be writing mu is equal to the true mean, and then blah, blah, blah. The next thing that we're going to do is plan. So in our plan stage, we are checking conditions. Do you remember what the conditions are? Yes, we do. It's the central limit theorem. Oh, so great. So great. So we're going to use the central limit theorem for a mean. There are really only two things you need to check off. The first is it random? If it's not random, go home. Oh, you're already home. The second is one of these three things has to be met. Either your sample size has to be greater than or equal to 30, or the problem says so, or dot plot is good. This means that the dot plot shows no skews, no strong outliers. You could even look at the box and whisker plot if you want, looking at some graph to see if it's okay. The third step is where we actually do everything. Get it? Do, because that's what it's called. This is where we're going to be using the formulas. The first thing that we have to do is figure out what is T star. Using table B, we're going to need two sets of information. We're going to need the degree of freedom, and we're also going to need to know what is the confidence level. Oh, we should add that up here. C%. So we're going to need those two things, and then we're going to be able to use the table to figure out what T star is, and we'll go over that in a second. And then you're going to actually physically do the formula x bar plus or minus T star times the standard deviation over the square root of the sample size. And then our final step is to conclude. So in our conclusion, I'll just rewrite it. So in our conclusion, what we're going to be writing is how does the interval relate to the problem? So we are blank % confident that the interval from blank to blank captures the true mean and then parameter and context. All right, so our example that we're going to be checking out is the one about marriage. It says in 1980, census results indicated that the age at which American men first married had a mean of 24.7 years. It is widely suspected that young people today are waiting longer to get married. We want to find out if the mean age of first marriage has increased in 2010. A random sample of 85 males had a mean age of 25.4 and a standard deviation of 5.12. Conduct a 96% confidence interval of the mean age of men's first marriage. So we're going to go ahead and start this problem off with state. So with the state, we want to write what we know. So in this case, we know that the null hypothesis is going to be a mu because it's a mean. And we know that that original mean is 24.7. Our alternative is still a mean. And we are trying to figure out if it is now greater than 24.7, which means that our null mu is 24.7. Remember, all three of these should always be the same number. So then we need to check out what is our sample size. So the sample size that they're testing out is 85. You can go ahead and do your degree of freedom, which is going to be 85 minus 1. So 84. Our sample mean, x bar, is equal to 25.4. And our sample standard deviation is 5.12. I believe that's all we said we needed to find in this section. And our confidence level. C equals 96%. So that's all for state. Let's go ahead and move on to plan. The first thing is it random? And it says right here, random sample, so yeah, it is random. The next thing is the sample size greater than or equal to 30? So 85, is 85 greater than or equal to 30? Yay! So it is normal by CLT. Okay, next step, do. The first thing that we need to do is figure out what is T star. So we know that our degree of freedom is 84. We know that our confidence level is 96%. So we're going to pull up table B. So with table B, that degree of freedom again was 84. Confidence level was 96. So at the bottom where it says confidence level, we're going to be looking at 96%. So we're going to be looking at this section right here. It even tells you that the tail end probability is 0.02. Then we're going to look through our degree of freedom, which is 84. But if you look, it goes from 80 to 84. It's kind of like the Price is Right. How close can you get without going over? And that would be at 80. So from 80, we're going to go over. And we're going to look at where it crosses that line. And that is at 2.088. So that is our T star. 2.088. Okay. I had to make sure that it was the right number. In case you were wondering, Socks is currently running around the table. He has decided to check out what is underneath the oven, and there's nothing there. So now he's going psycho. So if you hear a cat go crazy, it's him. We're not at this part yet. He's so distracting. All right, so anyway, we need to now figure out what is the confidence interval. So we're going to use the formula. The formula, x bar plus m minus T star times the standard deviation of the sample divided by the square root of n. So that's going to be 25.4 4 plus and minus t star, which is 2.088, times the sample standard deviation, which is 5.12, divided by the square root of 85. Your sample size, not your degree of freedom. We're going to do this twice. We're going to get a low number by using the minus, and we're going to get the upper bound. So many of you do not have an Nspire at home, so you're going to use Desmos, that online scientific calculator, and we're going to type it in. So we have 25.4 plus 2.088 times the fraction of 5.12 divided by the square root of 85, and that gives us 26.559. I'm just going to say 26.6. So that's the upper, 26.6. And then we're going to do the lower bound. So we're going to go back up here, and we're just going to delete the plus sign and put a minus sign. And that's 24.24. I'm just going to put 24.2. And we have to then write our conclusion. So in our conclusion, we are going to say that we are 96% confident that the interval from 24.2 to 26.6 captures the true, oh, we didn't define the parameter in context, the true mean age for when men get married. I actually looked at a survey that said that that is now higher. That's cool. So this is how you do your confidence level with a meme. The next thing that we're going to look at in the next video is how to determine the significance test so you can actually check your null and alternative hypothesis. So go ahead and go to the Google assignments and look at week 2, day 2, and that will give you your problem to practice. You're going to have 2 practice problems. Have a great day.